will see a demonstration where a person sits on a stool while holding a rotating wheel. But first, in order to understand this demonstration, you must know what Newton's first law is. Newton's first law states that if an object is in motion, it will stay in motion unless a force is applied or it is interfered with. Newton's first law also applies to momentum. It states that the momentum of an object will never change unless something interferes with it or a force is applied. The formula for linear momentum is P equals mv, where P represents the momentum in kilograms meter per second. The mass is the m value, which is measured in kilograms, and the v is the velocity, measured in meters per second. The formula for angular momentum is L equals mvr, where the L is the angular momentum, which is measured in kilogram radians per second. The m is again the mass, which is in kilograms. The v is the velocity in meters per second, and the r is the radius measured in meters. In angular momentum, the object is spinning or has internal spinning components. It can also be defined as the product of the moment of inertia and the angular velocity. In angular momentum, the velocity and radius are inversely related, which means that if the radius is decreased, then the velocity increases, and vice versa. This also exists in figure skating. When a skater is spinning, they start wide and they pull in. When they pull in, they decrease their radius, which therefore makes them increase in their velocity. In order for the physics bicycle wheel demonstration to work, the bicycle wheel mass must be concentrated along the entire wheel's rim, instead of the center, and that causes a larger angular momentum at a given speed. The bicycle wheel, the person, and the stool comprise a system that obeys the principle of conservation of angular momentum. Any change in the angular momentum within a system must be accompanied by an equal and opposite change, so the net effect is zero. That means that if the wheel is spinning one way, the person and stool will be turning the opposite way. And if the wheel is flipped, causing the wheel to spin the other direction, that will cause the person to also change direction and spin the other way. To change the direction, the person must exert a twisting force called a torque on the wheel. The wheel will then exert an equal and opposite torque on the person, which is Newton's third law. For every action, there is an equal and opposite reaction. Once again, when you spin the bicycle wheel and hold it in the air while on a stool, the bicycle wheel will cause the person to rotate the opposite direction of which the wheel is rotating. The rotating force of the wheel will cause the person to rotate as long as the chair has a low friction level. Therefore, the change in the angular momentum of the wheel is compensated for by the person's change in angular momentum. The system as a whole obeys the principle of conservation of angular momentum. This concept is directly related to riding a bike. A bicycle held up straight will fall over if let go of. However, the faster the wheels turn, the less likely the bicycle is to fall over. This is because the bicycle is trying to conserve its angular momentum.